Okay. Good afternoon to one and all. So, in the previous lecture of electrical machine first, that means for SYP class, we have discussed regarding Hopkinson test, and we have also discussed regarding Swinburne test, direct and indirect method of testing. We have already covered all the theory part related to unit number 3rd. This part we have already covered for SYA also. So this is just a revision part for SYA. Now today we will discuss regarding numericals based on testing of DC machine. That is numericals on Swinburne test, numericals on Hopkinson test. So we will discuss one by one numerical for Hopkinson test and for Swinburne test. Okay. So take one numerical. All of you write this numerical. Example number 1, all of you write a 220 volt DC shunt motor at no load condition takes a current of 2.5 ampere. The resistance of armature and the field are 0.8 ohm and 200 ohm respectively. Okay, 0.8 ohm and 200 ohm respectively. Estimate the efficiency of the motor when the input current is 32 ampere. Okay, we want to estimate the efficiency of DC motor when the input current of the machine it is near about 32 ampere. Okay, so all of you read the problem carefully and write down the given data. All of you write down the given data also. Okay, read the problem and tell me the given data. What is to be given? Okay. Before writing the given data, can anyone tell me whether this problem it is based on Swinburne test or it may be it is based on Hopkinson test? कशावरती प्रॉब्लेम आहे? स्विम्बर्न टेस्टचा आहे की हॉपकिन्सन टेस्टचा आहे? गिव्ह मी रिप्लाय. Read the problem. A 220 volt DC shunt motor at no load takes a current of 2.5 ampere. The resistance of armature and field it is 0.8 and 200 ohm respectively. Estimate the efficiency of the motor when the input current is 32 ampere. So this is the example is given. We want to calculate the efficiency of that motor or that machine when the current taking from the supply it is nothing but it is 32 ampere. Whether this problem it is, yes,
Swinburne test.
Swinburne test. Okay, right. So this problem it is based on Swinburne test. So we will discuss regarding some little bit overview regarding Swinburne test. So in case of Swinburne test, we are using or testing the machine, running that machine only on no load condition, right? आपण ती machine फक्त no load condition ला run करतो while performing the Swinburne test, बरोबर ना?
Yes, sir.
Now when machine it is running on no load condition, ज्यावेळेस machine no load condition ला run होते, at that situation we are taking some no load reading. So no load reading in the sense we require no load voltage, that means we obtain no load voltage, no load current taken from the supply at the no load running condition. Then speed, we are maintaining the speed of the motor at a constant value or a rated speed. So this speed it is also obtained. And after hot condition we are measuring the armature resistance, right? And after that, once we are calculating the constant losses, that means by conducting no load test we are able to calculate constant losses, right? आपण constant losses calculate करू शकतो, बरोबर ना?
Yes, sir.
Constant losses calculate करू शकतो no load condition वरून. We are able to calculate the constant losses from no load condition. So once the constant losses it can be calculated. So these losses are constant for all types of load. After that we are assuming a different load, or it may be desired load, it should be put on the machine. Then we are able to calculate the efficiency at any load. Once we have calculated the constant losses, ज्यावेळेस आपण constant losses calculate करू, after calculation of constant losses we are able to calculate the efficiency of that particular machine at any desired load by Swinburne test. We are not putting that machine on that much of load, we are assuming that desired load, we are just considering, or we are just assuming that desired load. Okay, then we are calculating efficiency. So you people already know the Swinburne test, how it can be carried out, which reading it can be taken, and how the calculation it can be done, because we have already covered it into practical also, right? So we have already covered practical. So see, write down given data. After given data we are calculating the constant losses. After calculation of constant losses we are calculating input power and output power. After that we are calculating the efficiency, right? So tell me given data, what is to be given? Tell me the given data. It's very simple problem, but it is important. Voltage is given, that means supply voltage V it can be given, that is we are considering no load condition, whether we represent V0 or V0 represent केले तरी चालेल, or V at no load condition, it is nothing but 220 volt. After that it will takes a current of 2.5 ampere, whether this is armature current or supply current. I will draw the shunt motor here. Here it is field winding of the machine. This one is the armature of the motor. This is the armature of the motor, and a supply is given to the top machine. It is nothing but 220 volt, right? 220 volt supply is given. Now see, supply voltage it is given 220. The no load condition, it will takes a current of 2.5 ampere, whether it is load current or armature current or field current. On the current, suppose this one is the load current, IL of 0. Again this one is the no load current, IA of 0. This one is the current, ISH. Tell me, what is this 2.5 ampere? It is the current. Which one current? Whether it is armature current or supply current.
Armature current.
Armature current. The motor it is at no load condition. No load condition la hai. That means secondary sides are current. Motor just take current from the supply, which is minimum current. So see, it will takes a current of 2.5 ampere. Kudun current geti supply kadun. So it is the supply current, that is IL0. It is equals to 2.5 ampere. Okay. So we will write here no load current taken from the supply, IL of 0. It is equals to 2.5 ampere. The resistance of armature and field are 0.8 ohm and 200 ohm respectively. What is to be given? Which resistance? Armature resistance is given, that is 0.8 ohm. Then field resistance is given, that means RSH is given, it is equals to 200 ohm. Okay. Now estimate the efficiency of the motor when the input current taken by the motor it is 32 ampere. आपल्याला efficiency calculate करायचे आहे. When the motor it will take a supply current, that means IL at somewhat load condition, or we are putting some load, assuming that much load. At that situation motor take a near about 32 ampere current, and we want to calculate the efficiency at this 32 ampere, right? All of you understood given data? What is to be given? Supply voltage is given. No load condition la motor run hote सांगितलंय, so that no load current taken from the supply it is equals to 2.5 ampere. You people know load increases, torque increases. To meet that value of torque, current taken from the supply it is also increases. Okay, so here no load current is given, then armature resistance is given, shunt field winding resistance is given, and we want to estimate the efficiency or the calculate the value of efficiency at current taken from the supply it is equals to 32 ampere. ज्यावेळेस motor 32 ampere current घेते, at that situation we want to calculate the efficiency, right? See, from Swinburne test we are able to calculate first no load losses, that means constant losses. पहिल्यांदा आपण constant losses calculate करतो. Then we are calculating the efficiency at that particular load, that means current taken from the supply it is nothing but 32 ampere. Okay, now see what is to be calculated from this. काय calculate करता येईल आता? फी आहे तुमच्याकडे, IL 0 आहे, काय calculate करता येईल?
P is equal to V into IL.
P is equals to V into IL. Which power at no load condition or at a load condition? कोणत्या कंडिशनची? सुरुवातीला कोणत्या कंडिशनची कॅल्क्युलेट करावी लागेल?
No load.
Ah, right. So no load power, that means no load condition ला supply कडून घेतलेला current आणि supply चे voltage, that means no load power taken from the supply. So do you know that because there is a no load condition, that means motor वरती load नाहीये, so power taken from the supply it is nearly equal to overcome the no load losses. No load losses overcome करण्यासाठी जेवढी power required आहे तेवढीच power motor काय करते, supply कडून घेते. So what are the no load losses or which are the no load losses? कोणते कोणते असतात no load losses? So no load losses it is nothing but core loss, in that eddy current loss, hysteresis loss. So this sum of the rotating part is there, so that there is a friction and windage losses is also there. So these all are the no load losses. No load losses. So see, no load power taken from the supply it is equals to voltage taken from the supply V0 into no load current IL0. So it is equals to 220 into current taken at no load condition, that is 2.5 ampere. So it is equals to
500 watt.
500
550.
220 into 2.5, 550 watt, right? So no load power taken from the supply it is nothing but 550 watt, right? Now this power, if I minus this if I minus the armature core losses, then I will get the constant losses, because the power taken from the supply at a no load condition it is only required to overcome the losses. जेवढे losses आहेत तेवढे overcome करता येतात, किंवा जेवढे losses overcome करण्यासाठी power required आहे तेवढीच power काय होते, supply कडून घेतली जाते. So no load condition ला there is a constant loss and the variable loss. Variable loss in the sense of copper loss. So copper loss which will be occur in the case of armature. Armature मध्ये copper loss occur will. So for calculating copper loss and if this copper loss it can be subtract from this no load power, we get the constant losses. Okay, no load power madhun jar mi copper losses minus kele, I will get the value of constant loss. Okay, now see what is the formula for calculating copper loss? No load copper losses. I will calculate here the no load copper loss. काय फॉर्म्युला कॉपर लॉस साठीचा?
Square.
हा, formula for calculating copper loss,
I square R.
Ia square Ra. So see, formula for calculating this copper loss, it is nothing but Ia. I am considering here Ia at no load square into Ra. You people having the value of Ra, whether you are having the value of Ia 0 or Ia no load? Ia no load ची value आहे का?
No, sir.
Okay, then how it can be calculated? What is the KCL equation at this point? Diagram मध्ये, this is the incoming current, this one is the outgoing current, this one is the outgoing current. What is the KCL? Incoming current is equals to outgoing current. So we want to calculate the IA0. IA0 calculate करायचं आहे. Apply the KCL here or the current equation, that is IL0. It is equals to IA0 plus ISH. I want to calculate the value of IA0. मला IA0 ची value calculate करायची आहे. So it becomes IL0 minus ISH. You people are having the value of IL0, that is 2.5. Whether you are having the value of ISH?
No, sir.
No. How ISH value it can be calculated? कशी calculate करता येईल?
ESH divided by RSH.
Okay, you people know the voltage across field winding and you are having the value of RSH. According to Ohm's law, V is equals to IR. So I is equals to V divided by R. V is nothing but, so voltage je ahe, voltage across this field winding, it is nothing but, in parallel the voltage remains same, it is nothing but 220, and resistance is given, resistance is equals to 200. So if I take a ratio of this, ISH is equals to V, that is 220 divided by R is nothing but 200. So 220 divided by 200, it is near about 1.1 ampere, right? So value of ISH is equals to 1.1 ampere. Use this value and calculate the value of IA0. So IA0 it is equals to 2.5 minus 1.1. किती आहे ती value?
1.4.
1.4 ampere. That is no load current, that is no load armature current taken by the motor. It is equals to 1.4. Now you people know the value of IA0. According to this, we are able to calculate the copper losses. याच्यावरून आपण copper losses calculate करू शकतो. So formula is already given here. No load copper losses, it is equals to no load copper loss, it is equals to Ia square, that is 1.4 square into RA. RA किती आहे? 0.8. So this is the value of copper loss at a no load condition. किती आहे ती?
1.56.
1.56.
1.56. It is nothing but near about 1.6 unit. Watt. So we have calculated the copper loss. You people know the input power taken by the motor. According to this, we are able to calculate the constant loss. So that means the constant losses, it is equals to constant losses. It is equals to constant losses. It is equals to no load power minus copper loss. No load power taken from the supply minus copper loss. So no load power, it is nothing but 550 watt minus copper losses, it is nothing but 1.6 watt. What is the value? किती येते value?
548.4.
548.4 watt. This is the constant losses, right? This one is the constant losses. Now, do you know that as per the Swinburne test, once the constant losses it can be calculated, we are able to calculate efficiency at any load. What I am telling, at any load we are able to calculate the efficiency. Now see, read the question. Estimate the efficiency of the motor when the input current is 32 ampere. Now when the motor it will be taking as a 32 ampere current, then we want to calculate the efficiency, right? All of you got question? क्वेश्चन लक्षात येतोय का बघा? आता नो लोड कंडिशनचा करंट 2.5 होता, त्यावेळेस आपण कॉन्स्टंट लॉसेस कॅल्क्युलेट केले. दॅट मीन्स फ्रॉम नो लोड रीडिंग we are able to calculate the constant losses. Once the constant losses it can be calculated, we are able to calculate efficiency at any load by Swinburne test. That means Swinburne technique, or we can call it as a indirect method of testing. Okay, see, we are giving here the estimate the efficiency of the motor when input current is 32 ampere. ज्यावेळेस input current 32 ampere आहे, at that situation we want to calculate the efficiency. So see, when input current taken from supply it is equals to 32 ampere, whether it is load current or armature current. That means whether it is supply current or armature current. Which one? कोणता करंट आहे? Give me reply immediately. Don't waste the time. Because we have already solved this problem. A division student, we have already solved. Which one current? Here clearly mentioned is that when the motor input current is nothing but supply current. That is, we are representing IL. IL is equals to 32 ampere. Now, see, when we are this current it will be increasing. That means as the load on the machine it will be increases. If the load on the machine it will be increases, the torque requirement of the motor it will be increases. To meet that value of torque, the motor it will be take that much amount of current which is sufficient to develop required amount of torque. We have already discussed the back EMF significance in case of DC motor, because it is self-regulating machine. जेवढा लोडला करंट जेवढा लोडला टॉर्क रिक्वायर्ड आहे, तेवढा टॉर्क डेव्हलप करण्यासाठी जेवढा करंट रिक्वायर्ड आहे तेवढा करंट मोटर काय करते? सप्लाय कडून घेते. So that means the motor it will take 32 ampere from the supply, because the load on the motor it will be increases. We are assuming that is it is indirect method of testing. See, the supply current taken from the supply it is nothing but 32 ampere. Now we will do the same process. याच्यामध्ये आपण constant losses use करणार. All other process remain same. We are calculating copper loss. After that we are calculating total losses. Then we are calculating input power. From that input power we are calculating the output power, and then we are calculating efficiency. Okay, see, now here the supply current is given. I want to calculate the copper loss. So formula for calculating copper loss, it is Ia square Ra. Again same, Ia is equals to IL minus ISH. So you people know the value of ISH and IL ची पण आणि ISH ची पण व्हॅल्यू आहे आपल्याकडे. So it becomes see IA is equals to, that is armature current is equals to IL 32 ampere minus ISH. We have already calculated ISH. It is nothing but 1.1, no? 1.1. So it becomes 30.9 na, 30.9 ampere. It is nothing but armature current. After that we are calculating the copper loss. So formula for copper loss, IA square RA, IA 13.9 square into armature resistance, it is nothing but 0.8. Calculate the value of PCU. Copper loss ची value calculate करा. Hmm.
764.
764. Okay, 764 watt. Now we are having the value of PCU. Also we have already calculated the value of constant losses. So total losses it is equals to sum of these two, 764 plus 548.4. So it is equals to किती ती value total losses ची
1315.
1315. 8 and 4 2 यायला पाहिजे ना, 8 and 4 12.
1312.4 येते सर.
Okay, 1312.48 na.
Yes.
That means 1312.5 लिहू शकतो आपण. 1312. So these are the total losses. Total loss. Now power taken from the supply when it will take a 32 ampere current. ज्यावेळेस ते 32 ampere current घेते त्यावेळेस घेतलेली power, it is nothing but again formula for power, P input, that is input power taken from the supply voltage V into current I. So supply voltage किती आहे 220. लोड कंडिशन ला घेतलेला करंट किती आहे IL, current taken from the supply, not for no load condition. Input current taken from the supply 32 no
32 sir.
So V into I केलं की याच्यावरून आपल्याला इनपुट पॉवर मिळेल. So all of you calculate 220 into 32. 220 into 32. किती आहे ती व्हॅल्यू
7040.
7040 watt. Okay, so see, you people know the value of power input, you people know the value of total losses. Total losses ची value माहिती आहे मला, power input माहिती आहे. So according to this we are able to calculate the power output. Power output calculate करू शकतो का?
Yes sir.
What is the formula? काय फॉर्म्युला P आउट चा? Power output it is equals to input power minus losses or input power plus losses?
Input power minus losses.
Okay, in case of motor, input power minus losses, it is the formula, that is 7040 minus total losses 1312.48. Calculate and tell me the value of P out. सांगा पॉवर आउटपुटची व्हॅल्यू 5727
5727.52.
ओके 5727.62 ना it is in bat
52, sir. 52.52.
52 52 का okay
Yes, sir.
okay 52. So this is the power output. Now we are having the value of P out, we are having the value of P in. According to this we are able to calculate the efficiency. Efficiency is a formula power output divided by power input. That means 5727.52 divided by 7040 into 100. So this is the efficiency when the current taken from the supply, it is nothing but 32 ampere. Saga efficiency
81.35.
81 point efficiency is equals to 81.39 ka
35.
35. Okay, 81.35% efficiency when the machine it will be running and it will be taking a current from the supply. It is near about 32 ampere, right? It is near about 32 ampere. Okay, getting लक्षात आलं का? This problem is very easy. Just you have to understand what is to be given and what is to be asked. काय दिलेलं आहे आणि how to solve this. What is to be given if we have missed the value of current given, whether it may be armature current or it may be supply current. Okay, जर armature current असेल तर there is a directly mention that motor taken an armature current of असा word असतो त्याच्यामध्ये, then we can read it, write it as a armature current. Okay, getting all of you? SYB
Yes, sir.
student, all of you getting no?
Yes, sir.
Okay, all have written this. लिहिले का सगळ्यांनी?
Yes, sir.
Okay, can I ref this one?
Yes, sir.
Okay, next one example, all of you write this example. Right, a 440 volt, second one example, a 440 volt DC shunt motor takes a no load current of 25 ampere. The resistance of shunt field and armature are 550 ohm and 1.2 ohm respectively. The full load line current is 32 ampere. Determine the full load output and efficiency of the motor. Again, same problem. Just we want to determine the different. That means we want to determine here output power as well as efficiency. All of you right? झालं लिहून? for
Yes, sir.
okay. See again, read the problem carefully, write down given data, same procedure to solve. Here the supply voltage is given, it is nothing but 440. I am not drawing here diagram. DC motor takes a no load current. So again the no load current taken from the supply, that is IL0, it is equals to 25 ampere. The resistance of shunt field and armature. Shunt field winding चा आणि armature चा resistance दिलेला आहे. First one, it is shunt field winding resistance, that means RSH, it is equals to RSH, it is equals to 550, and RA, that is armature resistance, it is equals to 1.2 ohm. The full load current is 32 ampere, म्हणजे full load current IL is equals to 32, or we can write IL of full load, it is equals to 32 ampere. Determine the full load output, that is power output at a full load. We want to determine, also we want to determine the efficiency. Solve करता येईल? All of you solve and tell me the constant losses. All of you try to solve. We will give some time for you. All of you solve, try to solve and tell me the constant losses. How many? What is the value of copper loss? What is the value of no load power input? Okay, we will solve. See, power on input at no load condition, that means no load power, it is equals to supply voltage 440, current taken from the supply at a no load condition. I think here again 2.5. Here it is not 25, here it is 2.5. All of you take this, make the change, that is 2.5 IL. 440 into 2.5, 1100 watt. Okay, now similarly this power taken at a no load condition, it is only due to overcome the no load losses. No load losses overcome करण्यासाठीची power आहे. So power taken from the supply, it is nothing but it is to overcome the no load losses, 1100 watt. Now we are calculating the copper loss at no load condition. No load condition चे copper loss calculate कर दो. So PCU or the copper loss, it is equals to IA square RA, that is IA0 square RA. I am not having the value of IA0, so IA is equals to IL0 minus ISH. So again I am not having the value of ISH. ISH is equals to supply voltage V divided by resistance, that is 550. किती आहे ती value ISH ची? What is the value of ISH?
0.8.
0.8. Okay. So 0.8 ampere. Again, we calculating the value of IA0. IL0 2.5 minus 0.8 it is equals to
1.7.
1.7 ampere, that is IA0. After that we are calculating the copper loss at no load condition. 1.7 square into resistance, armature resistance 1.2. What is the value? Copper loss
3.46.
3.43 watt. Right now
3.468.
468 ka?
Yes, sir.
Yes, sir.
68. 3.468 watt. Now we are having the value of power input at no load condition. We are having the value of copper loss at no load condition. According to this, we are calculating the constant losses. So constant losses, or we can call it as iron loss, core loss. Constant losses is equals to power input 1100 minus PCU, that is 3.468.
1096.532.
1096.532 ka?
Yes, sir.
It is in the watt. Okay. Once we know the constant losses, after that at any load condition we are able to calculate the efficiency. Okay. We not only we want to calculate efficiency, we want to calculate the power output also. आपल्याला आउटपुट पॉवर पण कॅल्क्युलेट करायची आहे याच्यामध्ये. बघा, सी अगेन फॉर हियर करंट at full load condition. Full load condition चा करंट दिलेला आहे. According to this we are calculating the value of copper loss, that is IA. It is equals to full load current 32 minus shunt field winding current, it is 0.8. IA at full load condition, that is armature current at full load condition, किती येईल value?
31.2.
31.2 ampere. We people having the value of IA, so we are able to calculate the copper loss at full load condition. Copper loss at full load condition. Full load condition चा copper loss IA square RA, so 31.2 square into armature resistance, that is 1.2. Armature resistance 1.2. What is the value? किती येते?
1186.
1182.
68.
1168.
1168.
0.128.
1168.128, right?
Yes, sir.
Okay.
Yes,
We have calculated the copper loss at full load condition. पहिल्यांदा नो लोड कंडिशनला कॅल्क्युलेट केला होता आपण, आता फुल लोड कंडिशनला कॅल्क्युलेट केलं. सो सी we are having the value of copper loss at full load condition, we are having the value of constant losses. So according to this we are able to calculate the total loss. Total losses, it is equals to sum of these two, 1096.532 plus 1168.128. किती व्हॅल्यू टोटल लॉसेसची? किती येते?
2264.66.
2264.62.
66, sir.
66. Okay, it is in watt. That is total losses. Total losses आहेत आपल्याकडे. Now we are calculating the input power at full load condition, that is P input. We are having the value of supply voltage 440 into current taken from the supply. It is nothing but 32. किती value आहे 704 sorry 7040 नाही किती येते
14084
0 14080 watt 14,080 watt. It is the power input. We want to calculate the power output at full load condition. Full load condition la power output calculate करायचे. P out at full load. It is equals to P in minus loss. That is total loss. P in आहे आपल्याकडे 14,080 minus 2,264.66 watt. किती येते output power? P out it is equals किती येते
one 11815
815.34.
815.34.
See, P out it is equals to 11815.34 watt. We have calculated first one, that is power output at full load condition, and now calculate the efficiency. So formula for efficiency, P out 11815.34 divided by P in 14,080 into 100 into, here it is into 100. So this is the efficiency at full load condition.
$83.91.
83.91%. Getting all of you? Okay, right? कोणाला काही डाऊट आहे याच्यामध्ये? Is there any doubt? Getting doubt आहे कोणाला काय?
No, sir.
Okay. So this is related to simple test. I will give one problem for homework. I will rub this. All of you try to solve. Okay. All of you write the problem. A DC shunt motor. A DC shunt motor gives the following result. Following results of Swinburne test. gives the following result of Swinburne test. Voltage 600 volt, voltage 600 volt, current 8 ampere, current 8 ampere, armature resistance RA 0.1 ohm, field resistance, that is RSH, it is equals to 300 ohm. Okay, बघा DC shunt motor आहे, it gives the following result. When Swinburne test it can be performed, ज्यावेळेस Swinburne test परफॉर्म केले त्यावेळेस हे रिझल्ट काय मिळालेत आपल्याला, voltage, current, armature resistance and field resistance. Now find the efficiency of the machine. Next line, find the efficiency of the machine, efficiency of the machine. First one, याच्यामध्ये पहिलं, as a generator delivering 100 ampere, delivering 100 ampere at 600 volt. This is one important question. Delivering 100 ampere at 600 volt. Second one, as a motor having a line current of line current of 100 ampere, line current of 100 ampere at 600 volt, at 600 volt. Neglect increase in resistance, neglect increase in resistance due to the rise in temperature, due to the rise in temperature, rise in temperature. Assume stray load losses as 1% of output, 1% of out. Read the problem carefully, all of you, and try to solve. It's again easy. Just one machine, it can be run one, that means same machine, it is run as a generator and it is run as a motor. Additional losses is given, that is 1% of 1% of output. This is the stray load losses. आउटपुटच्या 1% हे काय आहेत, स्ट्रे लोड लॉसेस आहेत. त्याच्यावरून इफिशियन्सी काय करायची, कॅल्क्युलेट करायचे. मशीनची व्हेन इट इज रनिंग ॲज अ जनरेटर, व्हेन इट इज रनिंग ॲज अ मोटर. ओके, ओव्हर. हॅलो, लिहून झालं का?
Yes, sir.
Okay, all of you try to solve. If is there any doubt, then directly ask. Okay, otherwise we will solve it in next lecture. But in the tomorrow's lecture you should having an answer of this problem. Okay, so in this way, we will conclude this today's lecture, and we will stop here.